Welcome to section 9.6 on synovial joints and levers. Our synovial joint movements could be compared to the mechanics of a lever system. So this plays into biomechanics, which is applying mechanical principles to biology. So when we think about these joints, we want to think of them in terms of levers. So we'll see that lever is going to be an elongated, rigid object that is going to contain or be rotating around a fixed point called a fulcrum. We'll have the effort that's applied at one point and the resistance or the load that is located at some other point. And the movement occurs if the effort exceeds this resistance. We also have our effort arm, which is the part of the lever that is from the fulcrum to the point of effort. And then our resistance arm that is going to be the distance from the fulcrum to the point of the resistance. So let's talk about our three classes of levers now. Our first class of lever is when we find that fulcrum to be in between our effort and the resistance. So an example of this in our everyday life would be like a pair of scissors, where we have the effort being the handle of our scissors, and then the fulcrum being where we have that joint, that screw within the scissors, and then we have the resistance being whatever we are cutting through. And in our body, an example of this would be our atlanto-occipital joint. So where those occipital condyles are coming together with the superior articular facets of our atlas or C1. We can see that our fulcrum would be right over here. Our resistance would be our chin or the weight of our head here. And then effort would be that muscle pulling it back, allowing for extension of our head. Our second class lever is when we have the resistance sitting in between the fulcrum and the effort. We'll see that a small force would be able to balance a larger weight. So the best example in our everyday life for this would be like our wheelbarrow, where we have the fulcrum being at the wheel at the very front. We have the resistance, whatever being in the wagon, and the effort being at the handles, you pushing it along. This is rare within our body, but we can think of it when we are standing on our tiptoes. Our fulcrum would be the balls of our feet, which would be the head of our metatarsals. Resistance would be the weight of our body pushing down, and our effort would be our calf muscles over here, allowing us to plantar flex. And what we have happening the most within our body are our third class levers, where we're going to have the effort sitting between our resistance and the fulcrum. An example of this in our everyday life would be like our forceps, where the very end is our fulcrum. We would have the effort being applied by our fingers here at these bars, and then the resistance would be whatever we are trying to pull or pick up with the forceps. And for our body, the best example is here in our elbow joint. We see the fulcrum will typically be where the joint is, and then we have the biceps tendon inserting here at the radial tuberosity, applying our effort. So when the muscle contracts, it is pulling against our forearm bone. And the resistance would be the weight of our forearm in our hand. Sometimes, of course, we can have something like a dumbbell in our hand, increasing the resistance, meaning that our muscle has to increase its effort in order to cause flexion.